Hello, welcome back to physics class. Still on simple AC circuit. In this video, we'll be taking a look at same resistance in AC circuit, capacitance, as well as inductance in AC circuit. So let's start with the first one, resistance in AC circuits. When a resistor is placed in an alternating current circuit, both the current and the voltage move at the same rate. That is, the current is neither ahead of voltage nor is it behind or lagging the voltage. So, as such, now we can simply say that the equation of motion from Ohm's law, V equal to IR, simply implies that what current is equal to V over R. So based on what we said now, since both current and voltage are at the same phase, they are in phase, then we can simply say that the general equation that says that V equal to V naught sine omega t could be transformed into current to be I equal to, since we have V here, we're going to have V naught over R sine omega t. You see, what we are saying here is that the resistance, the amount of resistance offered to voltage is still the same amount offered to what? The current. So as such, this gives us our I naught. Therefore, we can say that V equals to V naught sine omega t, and I equal V naught over R is I. So since there is naught, we're going to have I naught sine omega t. So we can say that resistance in an AC circuit, current and voltage are in phase. They are both in phase. So similarly, it means that the Vrms value is equal to Irms times resistance. So this is what we have for resistor in an AC circuit. And the second thing here we'll take a look at is the capacitance. Number 2, capacitance in AC circuit. When we have the capacitance in AC circuit, it is important for us to know that the current and the voltage are not exactly in phase, as in the case of resistor. So that is, current and voltage are out of phase. Therefore, we say that the voltage lags current. That is, the voltage is behind current. So I will not be giving a circuit diagram, just this kind of diagram here. Okay, let me do it in mini way. Just the same thing, but this time I will put the capacitor. This is symbol for the circuit diagram of capacitor. Same thing here, and we have our ammeter and the voltmeter around it. So now what is important for us to know is that the current and voltage are out of phase. That is, for capacitance in AC circuit, voltage lags current by the angle pi by 2, which is what, 90 degrees. So this is the phase difference between current and voltage in capacitor in an AC circuit. So if this is the case now, it simply means that when voltage is equal to V naught sine omega t, current will be equal to I naught sine, since there is a phase difference, we have omega t plus what? The phase difference. And our phase difference here, we say it is pi by 2. So this is what you have to know. And as such, we can now see that the resistance offered by the capacitor in an AC circuit, since it is not the same as the resistance offered by resistor, we can say that the resistance offered by the capacitor is known as the capacitive reactance. Capacitive capacitive reactance. It is just the resistance offered by the capacitor, and the symbol is X subscript C. And this is given by 1 all over 2 pi Fc. 2 pi Fc. In some textbook, you see it as 1 pi. 2 pi F is simply omega C. So take note of this. Then the next one I would like us to take a look at is when we have inductance in an AC circuit. Inductance in an AC circuit. When we have inductor, what is an inductor? You should have known that the inductor is a device, an electrical device made by what? Coiling wire around something of this nature. So the inductance is represented by letter L in the circuit diagram. This is the symbol and this is the letter. While capacitor is like this with letter C, resistor is this way or this way. Letter R, in some cases you might see something like this or like this. Please take note of the difference between the resistor and the inductance. The inductor is cold, but the resistor is a sharp edge. So like this, the one that with arrow are known as variable resistors. So they are still the same thing. So this is not what we're discussing. Let's put that aside and come back to the inductor in an AC circuit. When we have inductance in an AC circuit, okay, let's probably give another circuit diagram again. We have our source, and we have our ammeter, then we have the inductor here, and then we have the voltmeter connected across the inductor. So, and the current flows through this direction as usual. So we can say this is L and this is A labeled, and this is our AC source. So in this case, the current and the voltage are not also in phase. They are not in phase. That is to say, current lags behind voltage. Yes, current lags behind voltage by pi by 2 radian or 90 degrees. Remember, in the first case, current leads voltage. That is, if current is leading voltage, it means that voltage is lagging current. But in this case, we say current lags behind. That is, current lags voltage by pi by 2 radians or 90 degrees as usual. Then if current is lagging behind voltage, if current lags voltage, then it simply means that voltage is leading current. Another way you can say is that what voltage leads current. So it is still the same statement. In the other one, current leads voltage or voltage lags current. So take note of it, very important, by an angle of pi by 2. And in this case, the resistance offered by an inductor in an AC circuit is known as inductive reactance. Inductive reactance. Remember, they are just resistance and it is given by XL. Our inductive reactance XL is equal to 2 pi FL or omega L, where L stands for the inductance of the inductor. So remember, these are just opposition, they are what? Resistance. So it is measured in ohms. They are measured in ohms. So that is that for um, resistance, capacitance, and inductor in an AC circuit. In the next video, we'll be taking a look at the RLC series circuit. That is a circuit that contains resistance, inductance, and capacitance in series. So in this circuit, it is going to be, we are going to take a look at R and C in series, R and L in series, then the three of them in series, R, L, and C in series circuit. So stay tuned to get the full content on AC circuits. Thanks for watching.